Welcome. In this lecture, I'm gonna refactor the feet to meters program to constants. Alright, let's get started. If you remember, we built this program in the previous sections. It just converts the given feet to meters. Now I'm gonna add another feature to it. Now, besides meters, now it will also convert the given feet to yards and then it will print it. Let's do that. I'm just gonna declare a new yards variable. Then I'm gonna multiply it with 0.3333. This is another magic value. When you multiply it with feet, it converts the feet to a yard. Alright, let's print its result as well. Printf %g feet is %g yards, new line. Then I'm gonna pass the variables feet and yards. Okay, now it's ready. For example, let's run it with 1000 feet. Cool, now it converts meters to feet and yards. But can you see what's wrong with this program? Please pause the video and think about it. Alright, problem is this program uses two magic values. One is here, 0.3048. What is that? And the other one is here, 0.3333. As I said before, magic values are not good for readability and maintainability. It's better to use named constants instead of magic values like this. Now I want you to refactor this program to constants. I'll be waiting here. Just pause the video and try to do that on your own. Alright, I'm back. Now I'm gonna refactor the program using constants. First, I'm gonna declare two new constants for the magic values. Let's declare feet in meters with this ratio. I'm using this ratio because 1 feet is about 0.3 meters. Okay, now I'm gonna declare feet in yards with this expression. Feet in meters divided by 0.9144. This expression here converts meters into yards. Remember, feet and meters is in meters, right? So I'm dividing it with 0.9 because 1 yard is about 0.9 meters. Okay, now let's change this magic value here to feet in meters named constant. Alright, done. Now let's change this magic value here this time with feet in yards instead. Cool, it's ready. Let's try it. Now I'm gonna run it with 1000. Okay, it works as before. But we are not done yet. There are multiple constants here, right? So it's better to use a multiple declaration instead. Let's do that. Now I'm gonna first remove the second const keyword and this float64 type here. Then I'm gonna move the second constant next to the first one. I need to type another comma here. Okay, done. However, it doesn't work. But why? This is because feet in meters here will be declared when the whole declaration statement ends. Go says that feet in meters is not being defined or declared yet, so it doesn't exist yet. Well, clearly, I can't use this parallel declaration syntax here. Also, the multiple constant declaration is more readable. Okay, let's change it to a multiple constant declaration then. Let's wrap them inside the parentheses first. Then let's cut this second constant and move it here. And let's remove the commas. And lastly, let's add float64 types to each one. Okay, let's save it. As you can see, this time it works. In a multiple constant declaration, declaration happens after each line. So when this line ends, Go declares this feet in meters constant, so I can use it in this expression. But what happens if I change the type of the second constant to another type? For example, to float 32 like this. This is what happens. There is an error now. Go says that you cannot use a float 64 value with a float 32 value. So then I can convert it like this. Right? Now it works, but is it necessary? I don't think so. So let's remove the type and the conversion altogether. Voila! It still works. But how so? As I told you before, you can type it like this in a multiple constant declaration. So when a type is missing from a constant, it follows the type of the last constant. Look at here. Feet in yards has no type, right? At least it seems like it doesn't have one. However, it actually gets its type from the previous constant here. So its type is actually float 64. Let me show you. Now I'm going to print its type. Printf %t/n feet in yards. Alright, let's run it. As you can see, it prints float 64, and the program works. So it really gets its type from the previous constant feet in meters. Alright, let's remove this printf now. I don't need it. Actually, I don't need to declare a type for the first constant as well. It's because its initial value is a float literal, right? So the default type of a float literal is already float 64. I don't need to declare float 64 there. Let's remove it as well. Alright, let's run it now. Okay, as you can see, the program still works. And this also can help me in the future. For example, I can use this constant in any numeric expression. It's because it's an untyped constant now. This is also true for the second constant here. Okay, let's say that I want to change the feet in yards to a drag value like this. But I cannot do that. It's because you cannot change the value of a constant. Let's take it back. Now I'm happy with this program. However, it produces unnecessarily huge numbers like this. Actually, I could prevent it using a printf verb, but I want to show how to do it with another function, since I'm trying to explain constants right now. To do that, I'm going to use a function from Go standard library. It's called round. It rounds the given number to its nearest integer value. You're going to learn how it works in a minute. Let's call it from here. met.round. Alright. But there is an error. Go says that met.round is not a constant. It's because a constant belongs to the compile time, but a function call happens at runtime. So I cannot use it to declare as an initial value to feet in yards constant, right? But I can use it with a variable, right? Because it belongs to runtime. Let's do that. Now I'm going to call met.round here. So this expression converts the given feet to yards, then it passes it to the round function. And at the end, the round function returns another value from it. Let's check it out. I'm going to type go round main.go 1000. Cool. Alright, that's all. In this lecture, I explained almost everything about constants. Of course, there are still things that you need to learn. Please work on this program by yourself and solve the exercises. Thank you for watching. See you in the next lecture.